In this lesson, we'll focus on establishing a startup task, and we'll expand the startup task throughout the course, but for now, we're going to set it up. And since this is the first FreeRTOS task that we're creating, let's go ahead and create a task definitions file, and we'll keep this file in the config folder. So let's go to the folder and add a new header file. And let's call it FreeRTOSTasks.h. And first I'll add a descriptive title here so that what we're doing is clear. And we can also use this file as a general inclusion for creating FreeRTOS tasks. And to do that, we need to include task.h and FreeRTOS.h. Okay, then let's add a descriptive comment for the startup task so that this is completely clear. Okay, now let's define the startup task stack size and startup task priority, and we'll call the first definition startup task stack size. And 512 words should be more than enough. And I have a misspelling here, so I'll go ahead and fix that. Okay, now let's define startup task priority. And for the definition, let's use config max priorities from FreeRTOS config.h and just subtract 1 from here. Okay, so this is the maximum priority available subtracted by 1. And if we recall, that is defined here in FreeRTOS config.h, where we have the maximum priority set to 7. All right, so be sure that your FreeRTOS tasks file looks like this. And now let's go back to main.c and let's add the include for FreeRTOSTasks.h. Next, let's define the startup function, which acts as a wrapper around xTaskCreate, which kicks off the task creation process. This is a static function which we'll define just below main, so to ensure that the compiler knows about this function ahead of its actual implementation, we'll declare its prototype above main. Okay, so let's create a comment here, startup task prototype. And that's going to be static void startup, and it takes no parameters. Okay, and we'll define this function below main, so let's go down and make a bit of room here. And let's make a comment here and say, creates the startup task. All right, and the function is just the same as the above, static void startup. Now we can define the function. We're going to use configASSERT for our task creation, which, as we discussed, gives us the same assert semantics. So let's say configASSERT, and let's say pdpass for successful task creation. And now xTaskCreate. And the first parameter is the startup task function, which we'll define. So let's call this function startup_task. And the second parameter is for debugging purposes, which we'll see later. And we need to put this in quotes. So let's type startup task. The next parameter is the stack size. So let's use our startup task stack size. And the next parameter specifies any input parameters, and we have none, so that'll be null. All right, and the next parameter is the startup task priority. Then the last parameter is for the task handle, which we won't need, so this one is null. Okay, that's it, and this looks good. And I'll just make a little extra viewing space for us here. Okay, that's a little bit better. Now let's continue by defining the startup task. And what we're defining is the task function itself, which we've already mentioned is the first parameter to our xTaskCreate function here. So I'll go ahead and copy that, Control-C right here, and let's go up and make a comment. Startup task used for the required FreeRTOS initialization on startup. And that'll be static void startup task. Okay, in task functions, take a void pointer parameter, like so. And for now, all we're going to do is delete the startup task. And we'll just need to call vTaskDelete with a null parameter. So when vTaskDelete null is called within a task, it causes that task to delete itself, and the null parameter tells FreeRTOS that the task wishing to be deleted is the one calling the function. Now, before we use FreeRTOS by creating the startup task and starting the scheduler, let's update the SystemCoreClock variable by calling the SystemCoreClockUpdate function from the system.c file, because as we can see from the default startup file, the system init function will be called to update the clock, and we'll want to update the clock variable after this happens. And if we follow system init, we can see that this handles initializing the FPU, vector table location, and external memory configuration, and some basic clock setup as well. But again, we'll create our own clock setup in the coming lessons. But for now, let's leave it as it is, and let's continue in main. So let's go to the main function and call SystemCoreClockUpdate. But first, let's make a comment here. Update the system core clock variable required by FreeRTOS. Okay, then let's call system core clock update. Now that this is done, we can create the startup task. Let's call the startup function. Next, we'll need to start the FreeRTOS scheduler using vTaskStartScheduler. And once vTaskStartScheduler is invoked, FreeRTOS takes over, running tasks as they're scheduled and handling context switching between them. Okay, so that's all we need to do for now, and we'll fill out the startup task as we move along in the course. So let's take a short break here, and in the next lesson, we'll test out the startup task.